Welcome to the narrated notes that reviews global variables in scope. Now in Java, there were no global variables, but in C++ you were allowed to use global variables. Why did Java exclude global variables? What's wrong with global variables? Good programming style dictates that global variables should only be used when absolutely necessary. One reason is they take up valuable memory. Another reason is that in large programs, they make maintenance a nightmare. It's hard to track down who, where a value was set or changed if you declare it as a global variable. That means the entire project or program had access to using and changing the global variable. Now, we haven't written very many large programs, but when programs start to exceed 50,000-60,000 lines of code, this really becomes problematic. A third issue is that they make the subprograms less reusable or generic or general. Why? Well, you're relying on an entity defined outside of that particular unit of code. And 4, we will get into this soon, it introduces side effects to the program unit. More on that in a couple of weeks. So when we want to write good software, recall that we want to always take into consideration these two goals. 1, high cohesion. Each unit of the program, we want it to stand alone as a program module. Don't do things that are unrelated in one particular module or unit of code. Keep them small and single-purposed. The second design and coding issue is to minimize program module dependencies. This is called low coupling. We don't want the different parts of the program to be too dependent on other parts of the program. Now, we made a huge step forward when we went from structured programming in Comp Sci 0 to object-oriented programming in Comp Sci 1. One of the first things that you probably noticed was the lessening of parameter passing. When you're passing a lot of parameters around, you're increasing the coupling because the parts of the program have to share information through these parameters. With an object-oriented solution, we really cut down on that. And so that's a good thing. It's one of the strengths of object-oriented programming compared to structured programming in large programs. So now relate that to the previous slide. Do you see how these design goals of high cohesion and low coupling really lend themselves to not having global variables? We're going to examine this in a little bit more detail using structured coding with Python. Our first example will declare a global variable named global number, set its value to 100, and then we have a main function that prints global number. Before we get to main, we print the global number as well. I'm going to leave the PowerPoint notes now and we'll take a look at this code. So here's our global example 1. Global number is defined to hold a value of 100. The main function has just one line of code that prints out the global number, and we see 2 lines of code below the main, one that will print the global number from the global scope area, and then we call main, which also will print the global number. So let's go ahead and run this. We only have one variable named global number. It's declared globally. That means it's outside the scope or the jurisdiction of any function in this program, and therefore every function that gets defined in this program has access to global number. When you're first learning to use structured programming, it's very tempting to just go ahead and make things global, because then you don't have to worry about passing parameters. But that is really not a good way to go. It's a dangerous way to program. The next issue we're going to look at is how we could have a local variable that has the same name as the global variable. Once we do this and redefine a local variable that has the same name as the global variable, we lose access to the global variable from within that function. So inside main, we're going to declare another global number and assign it a value of 44. The scope of this variable is just inside main. Let's look at that in Python land. So our second example has global number set to 100 outside the scope of function main and preceding it. And then inside main, we now declare another local variable named global number. In most languages, when you do something like this, you are hiding the global variable. And now inside the local scope of main, global number will always find and use the local variable. So in this case, we see the value for the local global number is 44. So if we run this, we see global variable value 100, and then we call main, and inside main we change global number to 44 as a local variable and print that out. And just to show you that we now have two distinct variables, both named global number, let's add a line of code after main that also prints out global number. Okay, so let's make the ordering clear here. The first thing to be printed will be this line of code. The next thing will be inside main when we're using the local global number. And then finally, we will print the global variable one more time. Okay, before I run this, you should predict what's going to happen. All right, I'll run it now. Hopefully you recognize that even though we created and gave a value of 44 to a variable named global number inside main, it does not affect the global number, which still retains the value of 100. So that local variable, it gets created when main is invoked in its own little stack space. That activation record starts and the global number is local there, and as soon as function main is finished executing, it's like a giant eraser comes out and erases that local global number and its value of 44. However, the global number still exists, and so in our third print line we see the global variable's value is 100. All right, a little bit more about this name clashing aspect. We know we can't really have two variables with the same name to mean different things in one scope, unless there's really a way to distinguish them. So now this time in main, I'm going to attempt to use the global variable, global number, first in a print statement, and then make a local global number variable and assign it a value of 44. That will be our attempt to create a local global number variable that hides the global one. Then we will print that value out. Let's see what happens. We kind of gave it away. We've got a comment here that says it's not going to work, but let's find out what's going on here. I have global number, I call main, it will print the global number, but then it tries to create a local variable which has the scope of main, and then we want to print out its value. And Python is not happy here. Take a look at the last line there. It says unbound local error. Local variable global number is referenced before it's assigned. We really can't use both of these inside the same scope because we have a name clashing going on here. So what can we do? We kind of have to decide, are we going to use the global or the local? But we can't really use both. So this last coding example shows us how we can actually make a change to the global variable inside main. And in order to do that, we need to specifically call out the global number using keyword global. Then we can print the value to see that it has the value 100. And then we're going to change it here in main. Now because we called out global number with the global tag, we are able to change the actual global variable's value. And we are explicitly overriding that to have the value 44. So after main, the global number's value will have been changed. Okay, let's run this. So notice how this output differs from example 2, where we declared a local global number and that did not affect the global number. By calling out global number inside main, this gives us the ability to change its value or mutate the variable. So even though all of these variables within a function are immutable, right? We throw them away and get a new value. Global variables tend to behave differently. They are put into a separate area of memory and they exist the entire time the program's running. In this case, by using that keyword global, main actually changes the stored value for our global number. And we see that in the third print statement that happens after main, that its value has been changed. I encourage you to use these sample programs. I'll put the zip file in the module for this week. Play around with these things, experiment, get a good sense of how these behave. So some advantages of relying on local variables and staying away from globals is that you're only going to use as much memory for variables as you need at that particular time in the program. The memory is released when the subprogram is finished. It's much easier to find and fix errors in code that does not rely on a lot of global variables. You will build more reliable and more secure code by not relying on global variables. Reliable because there's not as much of a ripple effect in programs when they change. If you're relying on global variables, you're at the mercy of every other function in that program in terms of changing its value. Maybe the sequence calls of the functions gets altered, and that will then alter the way your code in that particular function behaves if it relies on a global variable. It's definitely more secure because we don't have to worry about different parts of the program changing values of our stored variables. A few final notes. Building large software systems is hard. The better our design and coding techniques will make a huge difference in how that project is able to be grown and extended. As the projects get larger and more complex, we really need to be careful about instituting good programming practices, such as high cohesion for each unit of code. Keep your functions small and single-purposed, and low coupling, so that they're not dependent on one another unless they really need to be. Also, understanding a language's scope rules and the method of passing parameters are critical aspects for being able to write anything beyond a very simple program in that language. Happy coding!